Jonathan, let's talk about tech birthdays.
Oh yeah, this week is August 16th through the 22nd.
What do we got?
First up, we have Larry Ellison.
Larry Ellison, born in 1944. This guy was a businessman, investor, who is a co-founder and executive chairman of the chief technology officer of Oracle Corporation. You know, Oracle Corporation, have you heard of them? Do you know what they do?
I feel like I've heard of them. I'm not sure what they're known for.
So Oracle began with a database. And I want to say that it was teamwork between IBM, Oracle, and Microsoft. And I could have my stories crossed here, but it was my understanding that Oracle, Microsoft, and Intel started creating a database server, I should say. And at one point, there was a disagreement as to operating system integration versus operating system segregation. And so they kind of they all had their different ideas as to how this database should operate within operating systems. And so I believe that Larry Ellison didn't agree with some of the Microsoft OS integrations that they wanted to do with the database. So at that point, they all took their the code base, the code that they have written, and they all went their own ways. So Oracle, SQL Server, and IBM DB2, they're very similar to each other, but also very different because, this was early. Oh man. Let's see if we can do a quick search on who originally started SQL Server. Let's see. So maybe what I'm thinking is that they were part of some consortium, because the SQL language, it's called Standard Query Language. So the acronym is SQL, or they pronounce it as SQL. Maybe they were part of some consortium that said, hey, here's the SQL language that can work across all databases. You know what I mean?
Yeah.
So maybe that's what this whole thing was about. Because there were definitely competitors.
Mm-hmm.
And so there is what they call Ansi Sql. And Ansi Sql, let's look up Ansi Sql. Ansi Sql. Yeah, structured query language. And so for relational databases, so it's RDBMS, relational database system. Data stream management. Oh, interesting. Originally based on relational algebra and tuple relational calculus. Yeah, so essentially, I think they were part of some consortium or something, and so they all have a common base of SQL, but then they also have their own, individual flavors of their programming for the SQL language. And so, but you can learn the Ansi SQL and it'll work across all relational databases and whatnot. But Larry Ellison, the founder of Oracle, and Oracle is actually, their database system is pretty awesome. Free for developers. You can download it and install it on your machine, and you can actually work with it and learn for free. They actually have a lot of training online, so some pretty cool stuff. Eventually, Oracle ended up buying Sun Microsystem, and they took all their technology. So all Java and everything is all within Oracle Corporation now, They ended up buying all that.
Wow.
So cool.
All right. Next up, we have Sergey Brin.
Sergey Brin. Who is this guy?
He is known for Google.
He, I
President,
think, co-founder.
co-founder.
Yeah. So he and Larry Page founded Google.
Okay.
I think on Larry Page's birthday, we covered the whole history of how they created Google.
Oh yeah.
Remember how they were at the university
Mm-hmm.
and they would use the computers that were coming in before. So they got a job like in the tech department at the university. So they would bring in new hardware. The school would get new hardware, but before they delivered it to its location, they would install their custom OS that would run Google, run some tests on it and whatnot, and then put back the operating system that the machine came with and then go deliver it. And so, yeah, they have an interesting story how they came up.
Pretty smart kids right there.
Yeah. Cool.
Yeah. Next up, we have Masatoshi Shima.
Man, that's a mouthful. What is he known for?
He's an electronic engineer who is known for the Intel 4004.
Yeah. When was the 4004 created? That's an interesting one. 1971.
Wow.
Is that the chip?
Why does it look like so archaic? Like he carved it with his hands.
I know. I think this is ceramic. This is ceramic, and then these are the copper connections. And you can see, like, you see where I'm.
Oh yeah. It's
like there's some kind of conductor there, but that conductor doesn't pass the full current. I think there's like some kind of resistance on that. Here's another conductor.
interesting. Yeah, there's some on the other side too.
Yeah. So I think it's ceramic, and within the ceramic there's a conductor, but that conductor doesn't send through the full current, the whole current, or all the voltage or amperage or something. It actually like has resistance. And then the gates for the processor are in this big block right here. That's pretty crazy.
Yeah.
So he invented, or he was the architect behind the Intel 4004 in 1971, and then that was discontinued in 1980 something, 81. So 10 years. Wow, this processor was dominant for 10 years.
Pretty neat.
Wow. Metal oxide semiconductor, silicon gate technology, the most advanced integrated circuit design undertaken up until then. So it lasted for 10 years because nobody can beat it.
I wonder what kind of stuff it was doing. Just math problems?
Well, I mean, the gates really come down to, gates being open or closed, right? So it's either on or off, like a light switch type of thing. How they get interpreted is what determines like the interactivity with the end user. So maybe this was basically for math. I guess they can connect it. Back then they were connecting them to TVs, huh? So you can actually like do some programming on your TV.
Wow, cool.
It would be good to take a like or either read of how processors work.
Mhm.
I know there's some YouTube videos out there that can show you how processors work, and the few that I've seen, they basically, I mean, it comes out to ones and zeros. What turns up on the screen is a result of a lot of ones and zeros, like for different things. Like if you were to take each and every pixel on your machine, you have 3 pixels RGB. What is it? Red, green, blue. And the amount of red, the amount of green, the amount of blue that you apply ends up making the color on the screen and whatnot. And so what they're receiving is a spectrum of red, a spectrum of green, a spectrum of blue. And depending what switches are on and off is going to be the amount of red, the amount of green, and the amount of blue that you get to light up. And so there's a bunch of circuitry that are making that determination. To us, it seems like, oh yeah, I go to this website and it's showing me, black and white and some blue and then a chip with a bunch of colors and different shades of brown and whatnot. But internally to the machine, it doesn't know what it's displaying to you. It's just interpreting instructions that are being sent to the different circuits of the machine and the screen. And that, to us, it's like it shows as intelligence. It's like, oh, the machine knows that I need to go to this website. The machine knows that when I type in this address, it should bring this information up. Where the machine really doesn't know. It's just interpreting the ones and zeros through its whole circuitry system.
All because of this Intel 4000.
Yeah. I mean, Intel is definitely one of the main players of circuitry and processors. Look at the speed of that. The CPU clock was 740 through 750 kilohertz. And it could only hold 4 bits with an address width of 12 bits on a multiplex.
Wow.
Now these processors are running 4 gigahertz.
4 gigahertz.
So yeah, so kilo is 1,000. Mega is 1 million. Giga
is a trillion.
Is a trillion, not gazillion, right? It's just a trillion. So yeah, I mean, 740 kilohertz is a drop in the bucket in comparison to 4 gigahertz.
Yeah.
That's crazy. And these are 4 to 12 bits. Now these processors are 64 bits. So they can store a much larger number of when it comes to math problems.
Pretty crazy. I can't even count that high.
I know. Neither can I. Masatoshi Shima, thank you for the processors thank you for the processors that evolved into the processors that we now use today.
Yeah.
Cool. I think that's all we have, huh?
That's the end of the tech birthdays.
Until next time.
Peace out.